Professor Han, thank you for accepting our interview request. It's a great honor to talk to you, the winner of the Nobel Prize in Physiology at the conference of the National Academy of Sciences Education. You made discoveries that changed the way we understood how cells work, how they divide. What first sparked your curiosity in science?
Well, for as long as I can remember, I was interested in science. I mean, when I was a little boy, I liked making crystal wireless sets and taking things apart and putting them back together. And we found in the back garden there was a lead mine. It was actually some old cottages or something which had fallen down, and they had lead pipes and which we could follow. And then we built a furnace to melt down the lead. And
Very healthy.
yes, I didn't apparently, well, maybe I did suffer. Maybe I've been really brilliant if we hadn't done that. But then the thing that really turned me on, I had a wonderful science teacher at the Dragon School who was called Gerd Sommerhoff. He was a German, actually a theoretical biologist. I mean, like many of my science teachers, he had a PhD, remarkably, but he made science fun and he made science simple. And it was he who taught me that I was good at biology, because he set up an exam which the whole school from the ages of 6 to 14 or something, 13, took. And I came out, while I was in the middle of the school, I came out very near the top. So from then on, I knew that biology was easy subject for me. It came naturally. I didn't have to study. So although I wasn't particularly interested in, I would have much rather been an electronic engineer, you understand. But I also had a friend who was a very good physicist, and he taught me that I was a useless physicist. So I was incredibly lucky, I think, in retrospect, that I was put on this career path early on, and then it just took off from there. And I was also lucky to be born when I was born, because, you know, the structure of DNA was worked out when I was 9 or 10 years old or something like that.
Yeah.
And by the time I got to university,
Yeah.
it was in the air. And messenger RNA was discovered in the first year I was an undergraduate and things like that. So it was.
So you were on the right track.
I was on the right track, in the right place at the right time.
It's important. Looking back to your own student years, what advice would you give to your younger self or the students here today?
Well, the students here today, it's really hard to do that. I mean, I think I was lucky. I had wonderful teachers throughout my life, and also some wonderful colleagues. I mean, I didn't sort of really realize when I was an undergraduate in Cambridge how important my peers were, because actually we were, highly selected. The cleverest people, I suppose you could say, of our generation, but we had no inkling of that.
Only retrospectively.
Only in retrospect, and then we were just puzzled. I mean, it was very difficult. It was very, very hard work to make sense of the universe, and we struggled and helped each other, and complained when it was boring, and were excited when it was interesting, and sort of found our own way. I think you have to find your own way. I think that's really, really important. And we were always pulled by the lure of being, I mean, it was interesting. The very first tutorial in biology that I took in Cambridge, the tutor, we call them supervisors in Cambridge, said, what do you want to be? There were 3 of us in this little tutorial group, and all of us said we want to do research. Now, why the hell did we want to do research? I have no idea, but that's what we said, and that's what we meant. But where did it come from? I don't know, quite honestly. I really don't know. But it was something, maybe it was just a fashionable thing to say. But then we did, because we could see the progress that was being made in the recent past. I mean, a good example is the a brilliant series of lectures I heard from Jacques Monod on the regulation of the lac operon, how bacterial transcription was controlled. And I mean, you know, I just thought this is fantastic because this is so beautiful. How wouldn't it be wonderful to do something like that?
Yeah.
And you know, and we had lectures from Nobel laureates. And the other thing which was good in Cambridge was that you saw that in some cases you actually knew more than the Nobel laureates, and that they were a very heterogeneous bunch. I mean, they weren't all obvious geniuses, you know, some of them seemed to be quite ordinary people, but they were just, I think the only thing that I detected they had in common, they liked things to be fundamentally simple. They'd like to really, really understand things properly, you know, with no mess.
Yeah.
So that was a good lesson, that things ought to be, when you really understand things properly, it turns out that nature is simple.
Yeah, maybe that's why it is very important to have this program here in Hungary, because the Hungarian students also have the opportunity to have these impressions, and maybe these are important for them.
I think it's important to see what acclaimed scientists look like from the outside, because they, you know, you can get an impression of what they are, you know, and that they're human, you know. I mean, so it's within grasp, right?
Yeah.
They're not. It's not like you know. I mean, it's sort of different in a way from sportsmen who are just, you know, you can just see how incredibly talented they are at hitting a ball or kicking a ball or receiving a pass from the other side of the field and stopping it dead at their feet. I mean, it's obvious that those are things which are very, very, very difficult to do. Whereas in science, you know, it's sort of accessible, actually. You need a training, of course.
Yeah.
But
you have to be persistent.
When you have to be persistent. I mean, I think that's, and you have to be humble in the face of the evidence, you know. But and above all, you have to be curious. You have to wanted to desperately understand how things work, and you have to be ambitious, I think, to, you know, tackle important and interesting problems. But you also have to be able to attack those problems in bite-sized portions so that you don't get lost in a morass of partial answers.
Yeah. You told that you were lucky, but were there any failures in your career?
Oh, millions of failures.
That turned out to be important lessons or led to breakthroughs. So were there any?
Yeah. No, I mean, actually, the sort of my most important discovery, in a way, came from a total failure. So I'd been trying to study how protein synthesis was activated when sea urchin eggs are fertilized. And I started that in 77. I went back 79, 80, 81, 82. And by that time, I was really running out of ideas and had made zero progress. So when I stumbled upon this protein that went away, which nobody had ever seen before, you know, it was a lifeline, actually, because it set me free on a totally new path of investigation. So I can't tell you how lucky I was. And by then, I'm better at discovering things than I am at sort of pursuing them through to the very end. I mean, there are some much better science. I don't think I'm a particularly good scientist, actually. I know, well, put it this way, I know people who are much better scientists than me.
Yeah, but what does a good scientist mean?
Well, they can sort of solve problems in ways and disentangle, get at the truth of things which are much too complicated for my poor brain. So I'm a rather simple-minded person, you know, and I admire them. I mean, I think it's terrific. But I've had friends who were, you know, just streets cleverer than me. At one point, I almost gave up because in successive years, I think it was something like, when would it have been? You know, let's say 76, 77, 78, or something like that. I had 3 undergraduate students who came under my supervision at the time. And they were all much more brilliant than I was. You know, they've just fantastic grasp and scope and depth of understanding. And I thought I should give up at that point, because what was the point when these people who were so much better? But actually, you know, I'm the one who won the Nobel Prize, so maybe there's something there.
Yeah, and this gives you possibility to support the younger candidates, younger researchers.
Yeah. No, the thing I really enjoyed was teaching people in the lab how to do experiments and how the results of the first experiment would modify your approach to the second experiment and help in the design, and one thing leading to another. I loved that. Absolutely loved that. And whereas I'm not very good at teaching from books. I can only teach what I found out for myself.
From experience.
From experience.
And
yeah.
what is your experience here in Hungary with the students who are participating in this program? What were your questions?
It's a little bit variable. I sat I sat at the back of the lectures 2 days ago, and I noticed that quite a lot of them were playing computer games on their phone. But the talk was pretty difficult to understand, so I can't say I entirely blame them. On the other hand, the kids that we met today, for example, in the school, I was very impressed. I mean, they asked some really good questions. They spoke excellent English. They looked thoroughly engaged. You would be proud of them.
Mm-hmm. And why do you think such programs can be useful for the whole world?
Well, I think it's I mean, the idea that you can bring some real science. I mean, when I was at school, I was the secretary of the school science society, and we went around, we visited things. We went to the local gas works, and we visited Alcan Alumina, who were developing the Coca-Cola can at the time, and the telephone exchange, that doesn't exist anymore. You know, I mean, all these it was fascinating to see how they worked, car factories, all that sort of thing. One of the things was that one of the pupils at the school, his dad was a Nobel Prize winner, so we asked him to come and give a talk at the school. And I remember at the end, I asked him, I said, well, so why did you win the Nobel Prize? Because I hadn't understood, you know. And but you form an impression of these people. You see that they're only human beings, you know, they're real, approachable things. So I think, that role models are important, I think. I had very good role models in Cambridge when I became sort of, serious apprentice scientist, as it were. Because there were up the road all these people who'd made fantastic discoveries in basic biology, molecular biology. And, and one knew them and talked to them, and they were kind and attentive and helped you and stuff. And so that was a good example, I think.
Yeah, this is important. But what do you think? Is there a chance to have science real big impact on the future of the humanity?
Oh yeah, I'm sure. I mean, we don't, because we have no idea how much is unknown out there, right? I mean, it's amazing the progress that has taken place in my lifetime. Just amazing. I would never have believed. I mean, once upon a time, the only thing where you could sort of talk to your phone was in a cartoon.
Yeah.
Right? It's now
it's
reality. This is incredible. Absolutely incredible. And the idea that we understand, developmental biology. I mean, still lots of things in biology we don't understand, but things that I never thought we would understand, we understand extremely well. I mean, the only trouble is now we understand so much that it's very hard. When I was little, you sort of knew where the frontiers lay. When I was an undergraduate, I think you sort of we were more or less taught at the frontiers. Now I think the frontiers have advanced beyond the stages of. So I worry a little bit that the young are so sophisticated out there that it's difficult for them to get to the point where they themselves can make an understanding and a contribution. You sort of need to have a PhD before you can even start. But nevertheless, I mean, they're looking at things, and hopefully one sparks an interest that they want to know what's going on. And there's so much we don't understand.
Yeah,
Still.
I think there will be some tasks for the young people in science.
For sure.
Yeah.
Absolutely certain, sure. I mean, of the people we saw, very few will become successful scientists. But if we even inspired one, I think that's enough.
Yeah, I think, yes, I understand, and I agree.
And here in Hungary, you have such a proud tradition of excellence in science in the past. I mean, it's just fantastic.
I hope that it will be continued.
I think so. My guess is that will continue. I mean, science really knows no boundaries. The important thing is that you encourage it, you nurture it, you recognize it,
Yeah.
you foster it, and this program surely does that.
Thank you. Thank you for accepting our invitation. Thank you for the interview, and I wish you a pleasant stay here in Hungary.
Thank you very much. Thank you for inviting me. I love coming to Hungary, actually.
Thank you.
Both the food and the people are excellent.
Okay, thank you.